chasing waterfalls.
Welcome guys to today's class. In this video, we want to discuss experiments on simple pendulum. Yes, it is important to note that one of the objectives of this experiment is to determine acceleration due to gravity. Yes, that acceleration due to gravity, you know in your elementary school that it is denoted as G equals to either 980 centimeter per second square or 9.8 meter per second square. This is the equivalent or the value of acceleration due to gravity in centimeter per second square or in meter per second square. So the essence of this experiment is to determine this. That means when you perform this experiment live and direct, what you should be getting should be close to this value. Yes, if it is not exactly this value, the answer you will get should fall in this range. G equals to 954 centimeter per second square to 1006 centimeter per second square. This is the equivalence. This is the range of value you are to get. That means if you approximate this to nearest whole number, it will give you 1000. That is, if you approximate this to nearest hundreds, unit tens, hundred. If you approximate it to the nearest 100, you get 1000. If you approximate this to the nearest 100, it will give you 1000. If you approximate this to the nearest 100, it will give you 1000. Then if you approximate this is a meter per second square. If you approximate it to the nearest whole number, it will be giving you 10 meter per second square. So this is the range of value of acceleration due to gravity, and this is the exact value we know from our elementary school. That means if I've done with performing experiment on this practical, or if I'm done with this experiment, what I should be getting should fall within this range. If we are talking about centimeter per second square. Then if you are talking about meter per second square, you are to get 9.54 meter per second square to 10.06 centimeter per second square, meter per second square. So you have seen that these are the range of value of your word G. So the answer you are to get should fall within this range. Okay? Now, what you do, or the essence of this video, is for us to see how to perform this experiment without touching apparatus. That is to say, we have to pick a value of G from this standard value we have, or range of values we have. Why I am considering this aspect is because the L given to us is in what? Centimeter. Now, this is the first time you got, the second time you got, the mean time, that is this plus this divided by 2, the period, which is this over number of oscillation, and square of this. Remember, when you are done with this experiment, I advise you, please include precaution taken to do this experiment to this extent. So don't forget to include precaution while reporting your results. Now, I'll pick a value here that is close to 980 and use it in getting my table. That is how we manipulate. We say G is equals to So what you have to do is to perform this without touching apparatus. what you do is pick a value from this range of value that is close to 980 and use it as your G. G is equal to, I pick 970 centimeter per second square. Now this is the value I am to pick and use it with each of these values of L. Now my T is equal to 2 pi root what? L over what? G. Look at the value of, or the formula for our G. This formula, we knew it before now from our simple pendulum topic. So this is length and this acceleration due to gravity. With this formula, we will be getting the value for T and value for T squared. Now, to get our first period, we say 2 pi root, our L is 100, our G is 970. Then to get your second period, you say 2 pi root 90 all over 970. To get your third period, you say this is 2 pi root 80 all over 970. Okay, let's get their values. These values, we put it here. Our first thing is 2.02. We don't attach the second to it because already it has second on this top. Then this is 1.91. So the third T is 1.80. Want to get the next one, that is one of 70. We will say 2 pi root 70 all over 970. Then the next one, 2 pi root 60 all over 970. Then the next one, 2 pi root 50. 2 pi root 50 all over 970. Let's get their value. Okay? So you get it with your calculator. Check the last one. So I succeeded to get all these values you are seeing here using calculator. That is T equal to 2 pi root L, which is each of these values will be taken as a L all over 970. And whatever I got, I just put it to be in 2 decimal places. I put it to be in 2 decimal places so that they will be uniform. I don't include seconds to it because already the heading is bearing second. Then after this, I have to get this value, and to get it, I will be squaring each of this value of T, which is 2.02 squared. That will be 4.0804, 1.91 squared, 3.65 seconds squared, 1.8 squared, 3.24 seconds squared, 1.69 squared, 2.86 seconds squared, 1.56 squared, 2.43 seconds squared, 1.43 squared. That is 2.04 seconds squared. So we have succeeded to get the values of T and values of T squared. Now, as we have gotten all these values, we want to see how to get this value. Recall that mean time all over number of oscillation is equal to period. Now note that the number of oscillation given is 20 oscillations. Therefore, mean time will be equal to number of oscillation times the period. 20 times each of the value of T. So 20 times 2.02 will give you 40.40. 20 times 1.91 will give you 38.2. 20 times 1.8 will give you 36, 33.8, 31.2. So when the 20 is multiplied to each and every of these values, you will get here. Now, when you are done with that, you also recall that to get your Tm, you say T1 plus T2 all over what? 2. The first value of T plus the second value of T all over 2. That will be giving you that 2 times this will be 2Tm equal to T1 plus T2. And that will be giving you that therefore T2 will be equal to 2Tm minus T1. T1 is taken to be Tm plus or minus 1.00 seconds. That means that this minus 1 will be 39.40. This minus 1, 37.20. This minus 1, 35.00. This minus 1, 32.80. This minus 1, 30.20. This minus 1, 27.60. Then next is T2 will be equal to 2Tm minus T1. 2 times 40.8, 2 times 40.4 minus 39.4. That should be giving us 41.40. Yes. Then 2 times this minus this, that should be giving us 39.20. 2 times this minus this, that should be giving us 37.00. 2 times this minus this, that should be giving us 34.80. 2 times this minus this, that should be giving us 32.20. 2 times this minus this, that should be giving us 29.60. Okay, so we have succeeded to get our table of values for this experiment. We want to now see how you can know if you are correct from the slope you got. Okay? And so look at the formula relating T, L, and G in simple pendulum. That is T equals to 2 pi root L over G. Understood? There are two possible graphs one can be asked to plot in simple pendulum experiment. That is graph of T squared, that is in seconds squared, against L in centimeter, either in centimeter or in meter, and graph of L in centimeter or in meter against T squared in second what squared. Are you getting it? And so these are the possible graphs one can be asked to plot. Whichever one, that will determine what you have to do to this equation you have. Now let's go. I want to talk about T squared against L. Afterwards, I will talk about if I'm asked to plot L against T squared and see how the slope will look like. After getting the slope, we'll be able to deduce our G as well. Let's see. Okay. Now for the first one, that is T squared against L. I will go to this formula. What can I do this formula so that it will have T squared? What I will do is I will say square both sides. T squared is equals to 2 pi root L over G all squared. I am squaring both sides. because what you do in the left hand side is what you do in the right hand side before it will be balanced. Okay, t squared obviously will be t squared equals to 2 raised to the power of 2, 4. Pi raised to the power of 2, pi squared. Pi raised to the power of 2 is pi squared. Then square root is here. Square root is opposite of power of 2. So here will be L over what? G. So you have gotten t squared equals to 4 pi square L over G. Now from here, carry this L, bring it down. You will be having that t square is equals to t square over L is equals to 4 pi square all over G. Can you see it now? That means if you are asked to plot the graph of t square against L, what you'll be having is the slope will be equivalent to this. The slope will be equivalent to 4 pi square over G, okay? And so what you do now is recall that G constant is constant. I mean, G, which is acceleration due to gravity, is constant. And that is his main aim of performing simple pendulum experiment. That is to find acceleration due to what? Gravity. So that G is constant. In Earth or on Earth, you have it to be equals to 9.8 meter per second square or 980 centimeter per second squared. But because no one is perfect, error can come in while performing this experiment, and so there is always a range one should meet up before he can be accepted. Okay, for this the range is 9.54 to 10.06 meter per second square. Then for this is 954 to 1006 centimeter per second squared. Okay, and so that is about that. So what we do, since this is the possible range we should note or take note of, we have to apply them here. We are talking about 4 pi square over G, and we will do it in respect to meter per second square. We'll do it in respect to centimeter per second square. Okay, let's go. For this one, we have it to be 4 pi square all over G is 9.54. Whereas for this one, 4 pi square all over 10.06. Okay? And for this one, we will say it is 4 pi square all over 954. Then for this one, we also say 4 pi square all over 1006. That is in centimeter per second square. Now, if you do the one of 4 pi square, all over 9.54, you will be getting 4.138. Then if you do 4 pi square all over 10.06, you will be getting 3.924. Both are in meter per second square. So you notice that this number is bigger than this. So we say start from the lowest. The range is between 3.924 to 4.138. This is when you are talking about t square against L. And the unit is a meter per second square. So this is a possible range you should get. So your answer should fall between this range. Okay? Then for this one, 4 pi square all over 954. 4 pi square all over 954 will be giving you 0.041. 4 pi square all over 1006 will be giving you 0.039. Both are in centimeter per second squared. Okay? And so what you'll be having is, since this is bigger than this, we say the range for this is 0.039 to 0.041. 0.041 centimeter per second squared. And so if I am plotting with centimeter and time second square, I should know that the range should fall in this. So if your answer didn't fall in this range, you are wrong. If your answer is not in this range, you are wrong. If your answer is not in this range, you are wrong. Okay, then we've been able to see the slope. That means if you are getting 3.924 as your slope, that means your G is equivalent to 10.06 meter per second square. That is when your length is in meter and your T square is in second square, which is always in second square most time. Then if you are getting 4.138, your G automatically was 9.54. Yes. So that means if you're able to get your slope, since your slope is T square equals to 4 pi square over G. That is when you are plotting graph of T square against L. Are you getting it? That means this slope I got, if I'm to deduce my G, I will say cross multiply. This is my slope, T square over G, which is equivalent to this. I will say my G, this will come up. This I'll take it to be my slope. Slope equals to 4 pi square over G. Therefore, my G is equals to 4 pi square over slope. Yes, that is how to deduce your G. If you do not want to plot the graph or even perform the experiment, that is how you deduce your G. Just pick a value. In our video on that channel, we pick 970 cm per second square. We pick 970 cm per second square, and we use it to teach how you can manipulate your values, plot your graphs, and answer some questions. And so 4 pi square over slope, 4 pi square over this slope will be giving you what? 10.06. 4 pi square over this slope will be giving you 9.54. 4 pi square over 0.041 will be giving you 954 centimeter per second square. 4 pi square all over this, which is your slope, will be giving you 1006 centimeter per second square. So note this: if you are asked to deduce your G after plotting it, after doing your graph, your experiment, everything, deduce your G. Look at how to deduce it. 4 pi square all over the slope you got. Yes. And so we have seen that if one, after calculating his slope, it didn't fall in this range, and he's plotted a graph of T square against what? Length. And that length is a meter. It should fall in this range. And if the length is in centimeter, it should fall in this range. Also, the slope, after getting it, your G is 4 pi square over slope. Please note it. Then we go for the one of you plotting the graph of L against T square. Yes, please try to check the channel, Chidon's Daniel. Once you check it, try to type maybe physics practical. You'll see a lot of things on physics practicals. Yes, so that you can watch and learn a lot. Okay, for the one of L against T square, that means from this formula I have here, I have to modify it so that L will be at the numerator and T square will be at the denominator. So look at how I will do it. G will come up and T square will come down. We have G equals to 4 pi square L over T square. Yes, what I just did is I carry T square down and carry G up. I am considering this one now. I'm considering the second one. When you are asked to plot the graph of T, L against T square, whether it's in meter or in centimeter. Let's check. Then what happens here is that this 4 pi square will come this side. It will be giving you G over what? 4 pi square is equals to L over T square. You have seen it now. Plotting graph of L against T square. That is giving you G over 4 pi squared. Okay? And so, going back to what we have here, we said that if it is meter per second square, the range will be this to this. Okay? That means for this one, for 9.54, I should be having 9.54 all over 4 pi square. Then for the 10.06, I should be having 10.06 all over 10.06 all over 4 pi squared. That is the range. We are considering the range now, which we say is between 9.54 again, and this is the G we are talking about, the acceleration due to gravity, which is the major aim of performing simple pendulum experiment. Then we also said that for this one, this is 954 all over. So what is this unit? This unit is meter per second squared. That is this unit. That is about this unit. So this is 4 pi squared. Then you will be also having all over 4 pi squared. That is in centimeter per second squared. Okay? Okay, so that is about this. Remember, this one we said is a graph of what? T square against L. Please, T square against L is opposite. T square is second squared against what? Second squared against meter. That is for this. And this one is second squared against centimeter. Please take note of this correction I just made here, because we are plotting the graph of T square against L, and so your slope should be second square over meter if L is in meter. Then for this one is also second square over centimeter if the L is in centimeter. But for this one of L over what? T square, this is meter per second square or centimeter per second square. Then for the one of 9.54 in terms of meter per second square, we'll be having 0.242 and 0.255. So that is in meter per second squared. So for the one of centimeter per second square, this is 24.17, and for this one, this is 25.48. That is in centimeter per second squared. So you've been able to see the value of your slope, possible value for your slope. If you are plotting the graph of L against T square, look at the possible values. If you are plotting the graph of L against T square in terms of centimeter and second square, in terms of meter per second square, look at it. In terms of centimeter per what second square, look at this. Since we have our G over 4 pi square to be equals to what? To be equals to slope, to be equals to L over T square, which is the slope. If we are asked to get your G, what you now tell them is that therefore, making G subject of formula, G will be equals to 4 pi square times your slope. So G will be equals to 4 pi square times your slope. In this case, it will be centimeter per second square or meter per second square. That is value for your G after solving. So it depends on the unit of your length. It depends on your unit of your length. That is it. Remember the correction we made here? We said t square against length, that is s second square over meter. For this one, second square over centimeter. So take note of the correction. Then for this one, this g, the unit will be centimeter per second square or meter per second square, depending on the unit of what? Your length. That is depending on the unit of your length. I think we have been able to talk about this without performing the experiment, plotting the graph, and giving ourselves headache. You can sort it out with the formula so that you know if you are correct or if you are not correct. Thanks for watching the video. See you next time.